If a wave is represented by y equal to a sin a t minus bx plus c, where a is amplitude, x is the position at time t, a, b, c are constants, dimensions of these constants are. That is, we are going to find out the dimensions of a, b, c. Here, equation is the form of y equal to a sin theta. Here, this represents theta. So, each term is theta only. So we know that theta is dimensionless, or dimensionless means we can write it as m raised to 0, l raised to 0, t raised to 0. So that is equal to 1. Each term raised to 0 is 1. So 1 into 1 into 1 is 1 only. And in this equation, each term at we can write 1. Similarly, bx we can write 1. Similarly, c also we can write 1 because all are dimensionless only. And from this one, a t equal to 1 means a equal to 1 by t or 1 by dimension is capital T or t raised to minus 1. Similarly, from this equation, p equal to 1 by x, where x is the position, that means it represents length only. That is 1 by L or L raised to minus 1. And here C equal to 1. 1 means dimensionless, or we can write M raised to 0, L raised to 0, T raised to 0. So the option is B. Correct option is B. Velocity V, force F and W, work W are taken as fundamental quantities, then dimensions of mass will be. Options are given, we have to find the dimension of mass. We already know work is force into distance, that we can write force is ma into distance. Mass into acceleration is velocity by time into distance, that is W. And from this equation we can find out mass. Mass equal to, we can take all the terms to the left, so W into T divided by V into D. Or we can write it as W divided by V into, we can rearrange this as d by t, or W by V into distance by time is velocity V, or we can write W by V square. So how mass is related? Mass is related to work. So we can write, if it is a fundamental quantity, we can write W raised to 1, again 1 by V square, that is V raised to minus 2, and there is no term of force, so we can write F raised to 0. So which term is correct? F raised to 0, V raised to minus 2, and W raised to 1. Option D is the correct one. Which of the following is the dimensional formula for energy per unit volume? We know that work done is stored as energy. So instead of energy, we can write work per unit volume. Volume is L cube. So work, equation for work is force into distance divided by L cube, that is distance cube. So you will get F divided by distance square, or we can write for force, the dimensional formula is mlt minus 2, and for distance it is L, so L square, and this will get cancelled, so we will get m L raised to minus 1 t minus 2. So our option B is the correct one. The fundamental frequency of vibration of a stretched string is given by n is equal to 1 by 2L root of T by M. Dimensional formula for M is, the options are given. Our equation is n equal to 1 by 2L root of T by M. Let us take the squares on both sides, that is 1 by n square equal to 1 by 4 L square T by M. From this we can find M. We will take M to the other side. So M equal to 1 by 4 L square T divided by M square will come to the right side. So it is. Now let us take the dimensions. 1 by 4 is a constant, no dimension. L is the distance, so it is L square. T is the force, so we can write ml T minus 2. Tension is same as force, so divided by, and n is the frequency, that we can write it as 1 by time. So n square we can write, instead of n square, 1 by t whole square. Here L and L get cancelled, and this t square will go upside also. So we can write m raised to 1. This will go upside, L raised to minus 1, and t raised to minus 2, and this plus 2. So t raised to 0. Our first option is the correct one. The force acting at a point is given by F equal to AT minus 1 plus VT minus 2, where T is the time in seconds. Dimension formula for A and B is. So from the principle of homogeneity of dimensional equation, the dimensions of all the terms should be same. Dimension of each term, first, second, and third, all the terms are same. So first term is having the dimension of force. So second term, that is AT minus 1, that also should have the dimension of force only, that is MLT minus 2, or A by T we can write MLT minus 2, or A equal to M, T will go this side, MLT minus 2 into T. That means MLT minus 1. Minus 2 plus 1 is minus 1. Similarly, third term is BT minus 2. That is BT minus 2. That also should have the dimension of force MLT minus 2, or BT square equal to MLT minus 2, or B equal to MLT minus 2 into T square, that is ML e raised to 0. So the correct option is ML T minus 1, ML T minus 1, and ML T 0. So option C is the correct one. Which of the following measurement is most precise? Option A 4.00 mm. Next is 4.00 centimeter. Next is 4.00 meter, and 40.00 meters. And this represents the LC part. Here LC is 0.01, and here also LC is 0.01, least count. That is here also 0.01, and here also 0.01. But this is in millimeter, this is in centimeter, this is in meter, this also in meter. And the instrument having minimum LC is most precise. Minimum LC is most precise. So from all of this is having minimum LC, because it is having 0.01 mm. This is the minimum one. So this is the most precise one. Option A is the correct one. The errors in the measurement of mass and velocity of particle are 2%, 4%. What is the error in the measurement of kinetic energy? We know the equation for kinetic energy is half m into v square. Errors will get added up in multiplication and division. So it is multiplication. Here errors will get added up, and this equation is of the form a into b raised to x. So when we consider the error in A and error in B, then it will get added up. And here is the power, and power get multiplied. Here in the question for mass, it is 2%. Error for velocity is 4%. So we can write errors will get added up 2 plus and error in V 4 into power is V square. So 2 into 4, that is 2 plus 8, 10. Error is the 10%. Option C is the correct one. Eighth question, number of significant figure in the product 1.021 and 0.05. In this one, in the question, see these are the two terms. So in this one, there are four significant figure. 1, 2, 3, 4, and 0 can be counted because it comes in between these two non-zero digit. And here, there is no non-zero digit here. So we cannot count this 0. Here only one significant figure is there. So in the result also, among these two, minimum is 1. So in the result also, among these minimum is this one. So one number of significant digit will be there. The question 3.5625 and 2.50. Correct significant figure is in this one 1, 2, 3, 4, 5 significant figures are there, and here 1, 2, 3 significant figures are there. This 0 can also be counted because it comes after this decimal point and it comes after the non-zero digit also. So in the result, if you divide this, you will get the result as 1.421. And how many digits we can take from this? Among these, this is the least one. So there should be 3. 1, 2, 3. And what about this one? Since this one is less than 5, we can neglect it. So the answer will be 1.4. Correct answer is option D. The pressure in CGS system is 10 raised to 6 dynes per centimeter square. Its equivalent in SI system is. We know that unit of pressure is Newton per meter square, and this is in SI system, and in CGS it is dynes per centimeter square. We know that 1 Newton equal to 10 raised to 5 dynes. So how we can write 1 Newton per meter square? Instead of Newton, we can write 10 raised to 5 dynes per centimeter. When we convert meter into centimeter, we will get 10 square. That is 1 meter is 100 centimeter. So 10 square whole square. It is 10 raised to 5 divided by 10 raised to 4. That is 10 dynes per centimeter square. From this, 1 dyne per centimeter square is, we can put this 10 into the other side. So it is 10 raised to minus 1 Newton per meter square. So 10 raised to 6. In this question it is 10 raised to 6 dyne per centimeter square. That is 10 raised to 6 into 10 raised to minus 1. We are converting it into Newton per meter square. So we will get 10 raised to 5 Newton per meter square. So answer is this one, A.